Hello viewers, today we are going to present the application of master slave flip-flop using NAND gate and JK flip-flop IC, and we shall demonstrate the same. Flip-flops are basic functional unit of digital memory. JK flip-flops are basic form of flip-flops which suffer a problem called race around condition. Race around condition is a problem where the output state of JK flip-flops become uncertain when J and K input is high and clock pulse is applied. To get rid of this problem, we can use what is called a master slave flip-flop. A master slave flip-flop can be constructed by using two JK flip-flops. The first flip-flop, called the master, is driven by the positive edge of the clock pulse, and the second flip-flop, called the slave, is driven by the negative edge of the clock pulse. In this way, the master slave flip-flop overcomes the race around condition. Now, let's move on to the experimentation. Today we are going to perform the experiment with the help of a trainer kit, as we can see in our screen. Now, let's see how many inbuilt sections are there in this trainer kit. The first section in the top left corner is the digital logic input section. In this section, there are 4 logic inputs, namely A, B, C and D. Here the logic low, that is 0 volt supply, is shown in black terminal, and logic high, that is 5 volt supply, is shown in red terminal. The preceding section is the clock pulse generator section. There is a push button switch in this section, using which we can generate positive logic clock pulse and negative logic clock pulse, which are connected in the green and yellow connector respectively. In the top right corner of the trainer kit, there is a output indicator section. In this section, we can check the state of digital outputs with the help of an inbuilt LED indicator. In case of logic high output, the LED will glow, and in case of logic low output, the LED will not glow. The next section is power supply section. In this section, a 5 volt DC supply will be generated, which can be accessed through red and black terminal. The master slave flip-flop using JK flip-flop IC section is placed at the top middle portion of the trainer kit. This section can be connected by toggling the inbuilt switch in upper direction. In this section, a master slave flip-flop is constructed using JK flip-flop IC. The last section of this trainer kit is master slave flip-flop using NAND gates. This section is placed at the middle lower portion of the trainer kit. If we set the toggling switch in down position, then this section will be connected. In this section, a master slave flip-flop is constructed using NAND gates. Now let's check the functionality of each inbuilt section of this trainer kit. First, turn on the setup. To check the functionality of DC power supply section, we shall use a multimeter. Now the multimeter has to be kept at 20 volt DC range. Let's connect the common probe of multimeter to the ground terminal of the power supply section. The other probe of the multimeter should be connected to the positive terminal of the power supply section. Here we are observing approximately plus 5.3 volt at multimeter screen. So we can conclude that this section is working as expected. Now we are going to check the functionality of digital logic input section. For this purpose, we are using a multimeter in DC 20 volt range. Let's connect the common probe of the multimeter to the ground terminal of the power supply section. Then with the help of second probe of multimeter, we shall check the DC voltage level at logic low and logic high input terminals of the digital logic input section. First, we shall connect the probe to the logic low, that is black terminal. Here we are observing approximately 0 volt at multimeter screen. Next we shall connect the probe to the logic high, that is red terminal. Here we are observing plus 5 volt at multimeter screen. Hence, as per convention, DC 0 volt is assumed as logic low and 5 volt as logic high. Now we shall check the functionality of output indicator section. At first, we shall connect one of the indicators with the logic low input by patch cord. Here we can see connected LED is not glowing. Similarly, let's connect the logic high input. Here we can see that the LED is glowing. Hence, this section is functioning properly. Let's check the functionality of clock pulse generator section. First, we shall check the positive clock pulse generator with the help of inbuilt output indicator section. For this purpose, we shall connect the green terminal of the positive clock pulse generator to one of the output LED indicators via patch cord. Now we shall apply a clock pulse by momentarily pressing the push button switch. We observe the connected LED gets on for few seconds and again gets off. Similarly, we shall check the negative clock pulse generator. In this case, we shall connect the yellow terminal instead of green one. Here we see the connected LED was glowing initially, which gets off for few seconds and turns on again. So the clock pulse generator section is fully functional. Let's start the experiment. We shall first use the master slave flip-flop using JK flip-flop IC section for our experimentation. This section can be connected by setting the toggle switch in its up position. First, we shall operate the flip-flop in its toggle mode. To do this, we shall connect both its input J and K to logic high input via patch cord. Then connect the output Q and Q bar to the output indicators. Clock input is connected to the clock pulse generator section. And clear input should be set to logic high state. Here we can observe that the output Q is at logic low state and output Q bar is at logic high state. Now we shall apply a clock pulse using the push button switch. Here we can see after the application of clock pulse, the output Q changes its state to logic high and the output Q bar changes its state to logic low. So the output has toggled their state. In this situation, if we apply further clock pulse, then the outputs will toggle again. Hence, we can say the flip-flop is functioning properly in its toggling state. At this moment, we may observe that the output Q bar is at the logic high state and the output Q at its logic low state. So the flip-flop is at its reset state. Now we shall switch the flip-flop to its set state. To do this, we shall connect the J input to logic high and K input to logic low state. Now we shall apply a clock pulse. After the application of clock pulse, the Q output become logic high and Q bar output become logic low. Now if we apply further clock pulse, the output logic state will not change. So the flip-flop is in its set state. Now let's take the flip-flop to its reset state. To do this, we shall connect its J input to logic low and K input to logic high. Rest of the connection will remain same. Now we shall apply one clock pulse. Here the Q output shifts to logic low state and Q bar shifts to logic high state after applying this clock pulse. Now we can see the output is not changing its state anymore for further application of clock pulse. As we can see in our trainer kit that we are applying clock pulses, but the output does not change its state. Hence, it is at its reset state. Now we shall operate the master slave flip-flop using NAND gate section in toggle state. This section can be connected by setting the inbuilt toggle switch to its down position. Now we shall connect both the J and K input to the logic high input using patch cords. Then connect the outputs Q and Q bar to the output LED indicator using patch cords. Similarly, we shall connect the clock pulse input to the clock pulse generator section. Here we can see the Q output is at logic low state and Q bar output is at logic high state. If we apply a clock pulse, then the Q output shifts to logic high state from logic low state and Q bar output shifts to logic low state from logic high state. So the output are toggling. If we apply further clock pulse, the output will continue to toggle. Here we can see with the application of each clock pulse, the outputs are toggling. So the flip-flop is working properly in toggle state. At this situation, we can see the Q bar output is at its logic high state and Q output in its logic low state. So the master slave flip-flop is in its reset state. Now to take the flip-flop to set state from reset state, let's connect the J input to logic high state and K input to logic low state. In this situation, if we apply a clock pulse, then the Q output shifts to logic high state and Q bar output shifts to logic low state. So we can say that the flip-flop in its set state. Now we shall move the flip-flop to reset state from its set state. To do this, we shall connect the J input to logic low state and K input to logic high state. In this condition, if we apply one clock pulse, then the Q output shifts to logic low state and Q bar output shifts to logic high state. So the flip-flop is in its reset state. Now, if we further apply clock pulse, then there is no change in the output state of the flip-flop. As we can see in our trainer kit, that with the application of clock pulse, there is no change in the output state of the flip-flop. So this section is working properly. The complete operation manual of this video is attached in the description box. If you really like this video, then please hit the like button. Subscribe our channel for more videos like this and press the bell icon to get notification first. Feel free to visit our website www.kalpanascientific.com at your convenience for any product related information. Thanks for bearing with us. Let's meet in upcoming video of this tutorial series. Till then, bye bye.